Hi friends, this video we are going to see solve this problem. Our aim is the given function is harmonic. Then I want to find v such that f of z is equal to u of x comma y plus I times v of x comma y is analytic. So what is the meaning? The given function is, so we have to find v, that is harmonic conjugate of given function. Harmonic conjugate of a given function. Then I want to find f of z in terms of z. Okay. First I want to prove that the given function is harmonic. What is meant by harmonic? Any equation satisfies the Laplace equation, that is called harmonic. First I want to start with the what is the Laplace equation. Laplace equation is d square u by dx square plus d square u by dy square equal to 0. So what is the u? U of x comma y is given that exponential of minus x times sin y minus y times cos y. Now I going to take derivative with respect to x. So I can take this is one function, this is another function. So first I take exponential of minus x times sin y minus y times cos y plus I kept exponential of minus x is as it is. Then I take derivative this one, we get the sin y. So this implies this is equal to minus x times exponential of minus x sin y plus y times exponential of minus x cos y plus exponential of minus x sin y. Next is I want to again going to take derivative with respect to x again. So that is d square u by dx square equal to, again I take, so I will take as minus x exponential of minus x sin y plus x times exponential of minus x sin y. Then here is exponential of minus times y exponential of minus x cos y minus exponential of minus x sin y. Now I have to compare these two. We will get minus 2 times exponential of minus x sin y plus x times exponential of minus x sin y minus y times exponential of minus x cos y. This is d square u by dx square. So to prove the harmonic, we want to find d square u by dy square also. First du by dy. So you want to take derivative with respect to y. So exponential of minus x times, if you take derivative with respect to y, you will get the same minus times, if you take derivative you will get the cos y only, you will get minus, here you take uv formula, minus cos y plus y times, because sin y is you get the minus, so that is why we get it again one positive. So x times cos xy minus cos y plus y times sin y. Now I am going to take derivative with respect to y again. So exponential of minus x keep as it is. Cos y you take derivative, you get then minus sin y. So minus x times sin y minus plus sin y. Here you will get then plus sin y minus plus y times cos y. We will get this one. So you will add together this one. So you will get the final answer. This one is exponential of minus x times sin y plus 2 times exponential of minus x sin y plus exponential of minus x y times cos y. Okay, this is d square u by dy square. So we already evaluated d square u by dx square. You look, this term is negative, this term is positive. So if you add together, you will get 0. And next is you will choose as this guy. This is the positive term. But here the same term is in terms of negative. So if you add together, it becomes 0. Then I am using this one is negative of y times exponential of minus x cos y, here plus exponential of minus x y times cos y. If you add together, you will get the 0. So this implies given equation is satisfies d square u by dx square plus d square u by dy square equal to 0. This implies u of x comma y, that is our given function, is harmonic. This is the first part I have done. Second part, we have to find v. What is my v? V is the harmonic conjugate. So I am going to use the CR equation. What is the CR equation? The Cauchy-Riemann equation is du by dx equal to dv by dy, du by dy equal to minus dv by dx. So what is the du by dx they given? We calculate the du by dx is, we find this is minus x times exponential of minus x sin y. So I will paste here. So we can copy. So du by dx equal to exponential of minus x sin y minus exponential of minus x times sin y plus exponential of minus x y times cos y. We have, this is equal to, from CR equation, this is equal to dv by dy. So then you required v of x comma y only. So you want to integrate partially with respect to y. So this guy is, if you integrate, so exponential of minus x integral over sin y dy minus exponential of minus x times x integral over sin y plus exponential of minus x integral over y times cos y dy. It's all about with respect to dy only. Dy missed. Okay. So now I am going to integrate this guy first. Integral over sin y dy is, if you integrated, you will get then minus times cos y. Then in here also the same only sin y, you will get the same answer. Next is this only I am going to integrate y times cos y times dy. This is equal to I am going to apply the integration by parts formula. So u equal to y, dv equal to cos y times dy, du equal to dy, v equal to, if you integrate you will get the plus times sin y only. So integration formula u times v minus integral over v times du. So this result u is y, v is sin y minus integral over sin y dy. So in sin y integration is cos y minus cos y. So this minus become plus y times sin y plus cos y. Now apply v of x comma y equal to, we get the answer is exponential of minus x times minus cos y. Minus time here is you will get the plus times exponential of minus x times x cos y. Then again plus exponential of minus x y times sin y plus exponential of minus x cos y. You look, these two guys are adding, if you get 0. So v of x comma y we got it as exponential of minus x times x cos y plus exponential of minus x y times sin y. Okay, this is, we got it. Next, plus the some integration constant, that is phi of x will be there. So I want to determine what is the phi of x. So I am going to take derivative with respect to x. So dou v by dou x, if you differentiate with respect to x, we get it as x minus time exponential of minus x times x cos y plus, if you take differentiate with respect to x, exponential of minus x times cos y minus exponential of minus x times y times sin y plus phi prime of x you will get. Next I want to compare the dv by dx equal to minus times du by dy. So minus times du by du means same exponential of minus x times x times cos y minus exponential of, so same thing only then the negative sign. So this implies, please compare it, phi prime of x is 0. This implies phi of x is some constant k. So v of x comma y is nothing but exponential of minus x times cos y plus exponential of minus x times y sin y plus some constant k. Now I want to construct the f of, this is the harmonic conjugate. This is the second part we have done. What is the third part they given is, we have to find f of z in terms of z. So this is the very tricky. You can imply where is the z will be there, x will be there. You can write z plus z bar divided by 2 and y as a z minus z bar divided by 2y. You can construct, that is very tedious process. So we can use this formula. It is very simple. You get the answer. What is the formula is f of z. F of z you can write as u of z comma 0 plus I times v of z comma 0. If you apply, you will get the very answer. So what is the u of z comma 0? So you put x is z, y is 0. So put y is 0, this guy is become 0. So this part there is no contribution. Similarly, y equal to 0, this part becomes 0. So, u of z comma 0 is 0. So, clearly, u of z comma 0 is 0. What is the v of z comma 0? V of z comma 0 is exponential of minus z. Here z will come, cos y is 1. So, v of z comma 0 is exponential of minus z times z, cos 0 is 1. This guy is 0 only, correct? Plus constant. So, this implies f of z equal to I times z times exponential of minus z, that I is common plus. This is the required function f of z. I hope you can understand how to prove the given function is harmonic and how to find the harmonic conjugate of the given function. And finally, if you know the real part u of x comma y and imaginary part v of x comma y, using that how to find the f of z in terms of z, okay, using this formula. Thank you for watching this video.